Hi, I'm Mr. Orr, and today we are looking at arc length and sectors, areas of sectors. Now, you'll recall that the circumference of a circle is 2 pi r. All right, so where r is the radius. So here we have a circle, and we are interested in finding the length of this arc right here. And to do that, the first thing we have to do is find the entire circumference. And the entire circumference is 2 times 5, which is 10 pi. So 10 pi is the entire circumference. Now, all I want is this portion. Now this is a central angle, so this is also a 50-degree angle, and the entire circle is 360. So what I want is 50 3/60ths of 10 pi. Okay, I can knock out a 0 here. I don't need that extra 0. So I have 5 over 36 times 10 pi. So I'm going to look at that on the calculator. 5 divided by 36 multiplied by 10 and then multiplied by second pi, and I get 4.36. So the length of this arc, in terms of units, if this is 5 units, then the length of that arc is 4.36 units. 4.36 units. All right, notice it's 50 degrees. That's one way of looking at it. But another way of looking at it is in terms of the number of units, not degrees, and that if this was centimeters, this would be 4.36 centimeters. All right, let's take a look at, now let me do a sector. We're going to do the same thing. I'm going to have a 50-degree angle, and here, and I'm going to still have this 5, but now I want to find the area of this sector. To do that, we have to recall the area formula for a circle. Area equals pi r squared. R is 5, so the area of the circle is 25 pi. Now, I want 50 3/60ths of that amount. So times 50 over 360, knock out a 0, and I get 5 over 36 divided by 36 times 25 times second pi, 10.91. So the area of that sector is 10.91 square units. So if this was centimeters, this would be centimeters squared. All right? Two different processes that are very similar, one to find an arc length and one to find the area of a sector. All right. I believe that may be all we need to cover here. So there is another problem type here that is a little bit more complicated. Why don't we take a look at one of these? Here you have these are kind of interesting. Here we have a circle, and we have a triangle here. Let me see if I can make that circle a little bit better. Here, then here from the center, we have a triangle, looks like this. And then over here, that's drawn down here, and what we're interested in is the area of that shaded region, and that's all we want. Now, you are given that this radius is 6, and let me see if you're given anything else. No, I don't believe so, except that this is a 60-degree angle right here, 60. Now, if these two are equal, so out of 180, I take 60 away, I have 120, I divide that by 2 because of the base angles theorem, and it turns out that I have an equilateral triangle. Okay, now, I'm going to do that, and then I'm going to have a 30 here and a 30 here. Okay, here's where we're going with this. The first thing we're going to do is find out the area of the entire circle. That's 6 squared pi, or 36 pi. Now, I want 60 3/60ths of that, which is 1/6. And that's because this angle here was 60 degrees. So the sector is a 60 degree. This is 60 out here, this arc. And therefore, I want 60 3/60ths of the circle, and that would be 1/6 of 36 pi, or 6 pi. Now that's the area of this entire sector right here. But notice I only want the shaded portion over here, so I'm going to have to subtract out the area of the triangle. Now, you may remember we have a formula for the area of an equilateral triangle. Area equals 1/4 s squared square root of 3. All right, s is 6, so it's 1/4 of 6 squared, or 36, times square root of 3. 1/4 of 36 is 9. So it's 9 square root of 3. So what I have then, I found the area of the entire circle, then I found the area of just this sector, and then I subtracted out the area of the triangle, which turned out to be equilateral, and I'm left with 6 pi minus 9 square root of 3, and that is the area. And now we could, of course, turn this into a decimal, but really this is the better way to show it, and that's the area of the shaded region. Okay, those are kind of fun. All right, that's it for this time around. Thank you very much.